Hello everyone, in this video I will explain what's Prometheus and where we use it and why is it considered such an important tool in modern infrastructure. After that, we will see the components of Prometheus and its architecture. Then we will look at a simple example of Prometheus configuration and get to know the core feature that made it one of the most popular monitoring tools, especially in environments that mostly consist of containers and Kubernetes, because these are dynamic and non-traditional environments. So let's get started. Prometheus is a tool designed to monitor containers and Kubernetes environments, but it can also be used in traditional environments where these are regular servers and applications deployed directly on them. Over the past few years, you will find that most people with containerized environment always use Prometheus or tend to use it. But the big question here is, why is Prometheus so important? And why do most people make sure to implement it? Over time, DevOps environments become more and more complex, and managing the environments manually becomes difficult. So here had to be the solution to manage these environments automatically. Usually, these environments look like this. We have multiple servers with containers or applications running on them, and there are many processes working on this infrastructure. Everything is connected in a slightly complex way to maintain these systems and keep them running efficiently without any of the application crashing, and that's a big challenge. Imagine having a complex infrastructure with many servers, and even better if these servers are distributed across multiple geographic locations, and we have no clue what's happening at the hardware or application level. For example, there could be a network card failure, or an application's response might be slow, or one server's memory might be fully used, or a server might have all its resources consumed and a lack of resources. In a complex infrastructure like this, many things can break, or in other words, the service or application we provide could stop, which could definitely affect the other services. Here, the problem is that we don't know exactly what's happening, and it takes time to investigate and fix it. Let's go ahead and take a more specific example. Suppose we have a server whose memory is fully used, causing a container responsible for the user database to crash. This database is used for the payment gateway service for our customers and the e-commerce application. As a result, users on the e-commerce site can no longer make purchases. This memory overload also slows down the UI or the dashboard response of our online store. Most users get frustrated and go to another e-commerce site offering the same service or product. So you might ask, so how am I going to identify the problem then? We start investigating until we reach the actual issue, which is memory consumption. Then we think about solutions and how to increase memory. Fighting the root cause would have been easier and faster if we had a system or a tool that continuously monitors these servers and alerts the responsible person as soon as the problem occurs. That way, we would know exactly what happened. Even better, if the system can detect the problem before it happened and sends an alert, responsible people can prevent the issue entirely. For example, this could monitor the memory consumption, and as soon as the consumption reaches a certain threshold, let's say 80%, it would alert the responsible personnel that the memory usage has exceeded the allowed limit. This way, our memory consumption is managed, and the tool could report the log collector, indicating that the memory reached its threshold. The responsible person can then check the logs, understand that the upcoming issue is memory related, and take action early to prevent any problems. This is where Prometheus becomes essential because simply provides this solution in an automated and organized way, making it part of the workflow. So what is Prometheus exactly, and what is its architecture? Prometheus has a main component called the Prometheus server, which performs the actual monitoring. It consists of three main parts: a database to store time series data, where all metrics like CPU usage and memory usage are stored. Second, we have the work component. This part is responsible for retrieving data, as we call it, the data retrieval. It fetches the metrics from applications, all servers, and store them in the time series database. In the last part, we have the HTTP server, which accepts requests common to Prometheus, allowing users to interact with Prometheus. This web server's API is used to display data on dashboards, either from the Prometheus dashboard itself or any other tool that can visualize this data like Grafana. Prometheus can monitor anything: Linux or Windows systems, application, NGX services, and more. In Prometheus terminology, these monitors entities are called targets, and each target has monitoring units. For example, if monitoring a server, the units could be CPU, I/O, or memory. If it's an application, units could be request count, duration, etc. These units are called metrics, and all metrics are stored in the time series database. Prometheus uses a human-readable text format to expose metrics. Each metric has help and type properties, making it easier to read and understand. Help is just a description of the metric, and type specifies the metric type, which can be counter, counts occurrences of specific event, gauge, measures the quantity or value at specific time, histogram, measures time or request size of an application. Prometheus works as follows. The data retrieval component pulls data from target using HTTP endpoints. For the work component to do this, data must be in a format Prometheus can understand, which is done through /metrics endpoints. If your service or server doesn't have the same endpoint, you need a traditional component called an exporter. Simply put an exporter in an extra service added to the target. It collects metrics and converts them into a Prometheus readable format and exposes them on the /metrics endpoint so Prometheus can pull the data. This data pull mechanism is a key feature of Prometheus. Most monitoring systems like Amazon CloudWatch use a push mechanism where the target pushes metrics to the monitoring system. Prometheus pull approach allows us to detect if a service is running or not and reduce network load because there is no continuous push traffic. You can see more feature in Prometheus documentation. I will leave the link in the description down below. To make all this work, we need to configure Prometheus. Prometheus configuration is done using a configuration file called Prometheus YAML. In this file, we define the target to collect data from and the interval of collecting data. Prometheus uses a service discovery mechanism to find target endpoints. Here is example of configuration file. It has several sections. The first one is global config, where we define scrape interval, how often Prometheus will collect data from target. Then we have rule files, which define rules for generating alerts. If storage reaches 70%, then it sends an alert. The scrape interval in the global section tell Prometheus how often to evaluate these rules. The last section is scrape configs, where we define the resources or targets Prometheus will monitor. You might ask, how does Prometheus send alerts, who receives them, and how does it handle all of this? This is where the Alertmanager component comes in. It sends alert via multiple channels, email, Slack, or other integrated systems. Prometheus reads the alert rules from the configuration file, and if the configuration is met, Alertmanager sends the alert according to the configuration method. So where does Prometheus store the collected data? And how can other monitoring systems access it? Prometheus stores data on a disk in a time series format, which is why traditional databases like MySQL aren't suitable. After storing the metrics, users can query the data using PromPtQL. For visualization, we can use tools like Grafana, which display data clearly and easily. So as we said, Prometheus cannot store data in a relational databases. It must use a time series database like Redis or other key value structured time series databases. If you enjoyed the video, don't forget to subscribe and like the video and share it with your friend who is still struggling to understand what is Prometheus. Further than that, see you in another video.